Welcome, Honors 8th grade math students. We are going to be doing lessons 1.1 through 1.4, and you just need to write down everything that I write down in your notebook. The very first vocabulary word that you need to know is a word called variable. A variable is just a letter. It is an unknown number that you plug in for the letter. And a lot of times people say, why are there letters in algebra? And we just use this letter, this variable, to represent the unknown. You don't have to have a letter. It could be a symbol. But you're probably familiar with X as a variable. All right, the next vocabulary word is constant. And this is a number that does not change. The next vocab is numerical expression. And that is something with constants or numbers and operations such as plus, minus, divide, and multiply. And the last vocab for a few minutes is evaluate. And that just means you are solving for a variable or an unknown. So, I'm going to give you a couple problems to do. And we are going to say that y equals 4, z equals 3, and x equals 8. You are going to do z plus y, a totally different problem, x divided by y, and a totally different problem, x times z. So go ahead and hit pause and solve those three little problems. All right, for the first one, hopefully you did 3 plus 4, which is 7. For the second one, you should have had 8 over 4, which is 2. And for the third one, 8 times 3, which is 24. So in this, you have variables, which is letters. You plugged in constants, the known number for it. And these were algebraic expressions, which will be our next vocabulary word. So an algebraic expression is a little mini equation with variables, constants, and operations. And chapter 1 really is review. So we're kind of moving fast. That's essentially the first section. The second section has another bunch of vocabulary words. So positive number. And the easiest way to think about that is just that you think of a number line. And the positive numbers are all right here in the positive part of the number line. And a negative number would be in the negative part of the number line. It is on the, you can say it's on the left of the zero, but sometimes people draw their number lines weird. So the next big one is absolute value. And the absolute value of anything is positive. So the absolute value of -3 is +3, and the absolute value of +3 is +3. So absolute value is a measure of distance. So basically, -3 is 3 spaces away from 0, and +3 is 3 spaces away from 0. And that is why absolute value is always positive. The next word would be opposite. And that is just two numbers whose sum is 0. So 2's opposite would be -2. And 10's opposite would be -10. Additive inverse is one of my favorite things because essentially if you have a negative, that means that you can add the opposite. So I like to call it slash and dash because essentially you are making it a positive and changing the sign behind it. So 2 minus 5 is the exact same thing as 2 plus -5. The additive inverse of -5 is plus -5. I'm going to give you 2 mini absolute value problems just to make sure, and then we'll move on to a bunch of number categories. So the absolute value of 5 minus 16 and the absolute value of 7 minus 3. Go ahead and hit pause. All right, you should have gotten the absolute value of -11, which is 11. And here you should have gotten the absolute value of 4, which is 4. Okay, we're going to talk about all the different ways to label numbers. So natural numbers are all of the whole numbers that are not negative. So they are basically positive whole numbers. Whole numbers five is a whole number. 8 over 2, that's a whole number because that's equal to 4. 0 is a whole number. Basically, they are positive. Integers are positive and negative whole numbers. In fact, if you write something like this, that means +3, and it also means -3. So integers include the negative. So -8 over 2 is an integer. Square root of 9 is an integer because that's positive and -3. Rational numbers, I'm trying to kind of get like bigger as we go. So rational numbers is everything except an irrational number. So it's fractions, decimals that stop, decimals that repeat. So 3/6, 1.12 repeating, 0.63 terminating decimals that stop. It's all the whole numbers, the positive, the negative, 0. Basically, most every number is rational unless it's irrational. Irrational numbers are numbers that never repeat and never stop, like a decimal. Put that. A very popular irrational number is the number pi. You can approximate pi as 22/7, but 22/7 is rational and it is not exactly pi because pi never terminates, it never ends, and it never repeats in a pattern. Like 3 will repeat in pi, but not in a pattern, like 3, 6, 3, 6. That does not happen. Some square roots also will fill up the calculator, like the square root of 2 is an irrational number because it's a decimal that never repeats in a pattern and it never stops. And then real numbers is everything on a number line. That includes rational and irrational. Okay, let's try a couple additive inverse problems. -4 2/5 plus 3 2/3. A second problem of -1 1/2 minus 3, and a third problem of -2 3/4 minus -5 3/8. Go ahead and hit pause. When you have these three done, hit play. All right, and the negatives in front is to just make them improper fractions. So 5 times 4 is 20, plus 2 is 22. So this is -22/5. And this is 3 times 3, which is 9, plus 2, which is 11. So 11/3. And then you need a common denominator to add. So we would need to multiply this by 3, which is the denominator here. And then this one, the denominator here is 5, so multiply these by 5. So now you have -66/15 plus 55/15. And then 55 and -66 is just -11. Probably the easiest way to do that problem. All right, in this one, if you do plus and negative, you would get -4.5. And over here, you have minus a negative, which is plus a positive, and the positive is bigger. You can take the 3/4. Remember, you have to have a common denominator, and this one is 8. If you multiply both of these by 2, you're going to get -2 6/8. So you really have 5 3/8 minus 2 6/8. Well, 5 minus 2 is 3. And 3/8 minus 6/8 is -3/8. So you've got a positive 3 and a -3/8. You're going to think of the positive 3 as 2 8/8 because that is 3. And then you've got the -3/8. So your final answer is 2 5/8. You could also make both of those improper if that is easier. Okay, we are on to section 1.3. Reciprocal is the first vocabulary word. And that is two numbers that when you multiply, you get 1. So the reciprocal of 1/2 would be 2 over 1. The reciprocal of 4/7 would be, you just flip it, so 7/4, and that would give you 1. Multiplicative inverse. Dividing by a number, you can multiply by its inverse. So, for example, 3 divided by 1/2 is kind of tough to think about. How many times does a half go into 3? Well, if you know it's 6, good job. But it might be easier to think of this as 3 times the reciprocal of 1/2, which is 2 over 1. And 3 times 2 is 6. The zero property states that 0 divided by a number is equal to 0, but a number divided by 0 is undefined. That does not exist. You cannot do that. 0 doesn't go into a number, ever. Let's do a quick little problem. Negative 60 divided by 15, negative 3 times negative 12, and negative 7/16 divided by 2 and 5/8. Go ahead and hit pause. When you're done, let me know. I think you are done. So, the first one, you should have gotten negative 4. The second one, you should have gotten positive, because a negative times a negative is a positive, 36. And in the last one, you're probably going to want to do 8 times 2, which is 16, plus 5, which is 21. And then you're going to want to multiply by the reciprocal. And when you do that, anything on top of the fractions can cancel with anything on the bottom of the fractions. So you can reduce 8 and 16 to make it a 1 and a 2. And you can reduce 7 and 21 to make that a 1 and a 3. You still have this negative. So now the whole numerator is negative 1 times positive 1, which is negative 1. And the denominator is 2 times 3, which is 6. So this is your answer. I also want to make sure that you understand, if somebody says 5 times x, you can write that a lot of different ways. That is 5 times x. If a dot is 5 times x, that x is 5 times x, which makes it kind of tricky. You can also use parentheses. You can put them both in parentheses. You could put just a 5 in parentheses, but all of these mean the same thing. All right, one more section today, a few vocab words. So if you have something like 3 to the 2, that is called power expression. So there's an expression with an exponent and a base. So this is called the exponent. Whoa. And this is called the base. If something is squared, it's to the power of 2. And if something is cubed, that is to the power of 3. And so 2 to the 3rd means you have 3 2's. 2 times 2 times 2, which is 2 times 2 is 4, times 2 again is 8. I'll give you a couple problems to try, and we will call it a day. 9 squared, negative 4 cubed, negative 5 to the 4th, negative 3 squared, 0 to the 7, negative 2 cubed. Which reminds me, I need to tell you the one last important thing, and that is that negative 1 squared is completely different than negative 1 squared. This first thing means that negative 1 is what is raised to the power. So this answer is actually, 1. The second thing means this power is out front and only the 1 is raised to the power. So this answer is actually negative 1. Now go ahead and hit pause and do those problems. All right, in the first one, you should have gotten 81. In the second one, that is a negative 64. The third one is a negative 625. The fourth one is positive 9, because negative times a negative is a positive. 0 to any power is 0. And in the last one, you have negative 8. That negative is out front. All right, hopefully this makes perfect sense and you are off to a wonderful start in 8th grade Algebra 1. Have a lovely evening.